Hello and welcome. Good morning, good afternoon, wherever you are in the world. I'm Mads Jensen here with SuperSeed. Today, we are going to go through a 2025 State of the Tech Industry update, which is similar to what we presented at the Investor Day we held last week with a few updates. The industry moves very quickly right now, so much happening, so much going on, and we're excited to share some of these updates with you. As we go through the main update here, as we think about what's top of the stack, top of the agenda items, kind of what are the three big topics of today of the tech industry. Well, the first one, clearly, the one that's shaping the world, the one that's driving not just the tech industry, but also really the business, climate, and environment, is artificial intelligence, which, as we know, has been moving markets not just in the past week, but really for the past several years. And as we then think about the second big item that we think is very, very important to cover in detail as we think about what's shaping tech and business and industry, well, the second big topic really also is AI. And no prizes for guessing the third one. Yes, it is AI, because we see AI really as the thing that's driving business right now across the world. And we'll unpack on the call this morning some of these items here and how some of all of that is unfolding. Now, in terms of AI, folks that have been working with us, following our talks and our writing and investing with us for some time, will know that this is not a new topic for us. We've been talking about AI for a while. In fact, in 2019, when Dan and I had the first launch event, kind of the theme and the title of the talk was that AI is changing the face of business. In 2022, when we had the first LP day in our current fund, was really coinciding with the launch of ChatGPT. And we talked about at the time how this changes everything. And then 2023, kind of our last major investor event here, where we spoke about how applied AI is the biggest opportunity in B2B technology tech history. And so there's so much happening. And of course, this is carrying into 2025. A little over a month ago, we outlined our predictions for 2025 for the year. And there were really, we had a number of different predictions, but I think kind of two main ones I want to bring up here is we said the economy also this year will be driven by AI and by evolution in AI. And that was the first thing. And the second thing we said was, look, the US AI dominance will be disrupted by China. And so we thought that would happen throughout the year. And I think it's fair to say that disruption came a little bit sooner, maybe than anticipated with DeepSeek's launch. Um, we're not quite correct to say launch. It was the launch of their Model R1, which came out a few weeks ago. And looking at the timeline here and how we led up to that major announcement and what happened on the day, December 26th, when everybody was busy tucking into their sort of delicious Christmas food and what else was going on. Not many people were paying attention to technology and AI model development. Well, quietly, DeepSeek released version 3 of their model, which was surprisingly good and immediately got some notoriety in the tech community. And that was part of what led us to say, look, we really think 2025 is the year when China is going to make a major disruption into the US tech dominance and AI dominance. Second major milestone here, January 20th was Trump's inauguration day. And while everybody was focused on what was going on in Washington, D.C., DeepSeek sort of quietly released R1, so their reasoning model. And again, mainly the tech community was paying attention. Everybody else was focusing on Trump and on the inauguration. On January 21st, Trump announced Project Stargate. So kind of this $500 billion project, all eyes still on DC. And it wasn't really until the weekend of January 25th, 26th, when people started waking up saying, well, actually, this could maybe be a major thing we're seeing here. And on Jan 27th, we had $600 billion wiped off NVIDIA's market cap. Now, over the last few days, as we are awaiting NVIDIA's earnings, we've seen the stock starting to climb a little bit back up again. Is that justified or not? But we'll try and unpack some of the underpinnings for NVIDIA's market position on the call here today. But before we go there, first up, let's ask why DeepSeek and the release of DeepSeek was such a big deal. NVIDIA was $600 billion down, but in the total tech industry, we saw more than $1 trillion wiped off market capital. So a very, very meaningful dent. And why was that? You could say, well, first of all, it's China-US rivalry. You've got the world's leading economy, and with the world's foremost emerging economy, emerging superpower, if you will, and that rivalry is always going to grab headlines when it's brought to the fore like this. The second major topic that we take away from this is the whole debate about open versus closed source. So whereas the leading model developers to date have been the closed source model developers, the OpenAIs and the Anthropics of this world, we've seen others playing catch up. Meta have had their Llama model, which is an open source model, meaning the source code is freely available for others to use. But what we saw with DeepSeek was a lot of innovation coming in an open source model, things that people hadn't done before. So this was actually less of a catch-up game and in some ways a leapfrogging game. And we'll unpack some of the technical underpinnings there a little bit, but it was very, very exciting development. The third point is kind of what was some of that innovation that was brought forward. It was the build efficiency, so lower cost to train, which is the thing that initially had many people scared vis-a-vis NVIDIA and the share price. Because what the DeepSeek team said was, look, we used much fewer processors to train the model, to build the model, than what OpenAI and Anthropic and X and Google and all the major US players have been doing. So, what does that mean for what's going to happen to the evolution of revenue and profit for these big chips manufacturers and NVIDIA specifically? Then we have operational efficiency, a much lower cost to run the model. This is important. This is really important. I'm going to double click and unpack on that specifically a few slides down. And lastly, innovation, genuine model innovation out of China. For years, people have been saying, look, the US is ahead, China is doing really well, lots of interesting research, but they're playing catch up. 6, 9, 12 months behind at least. What we saw here was genuine model innovation coming out of China. So research approaches that nobody had done before, nobody had thought of before. And of course, that got everybody very, very excited about both the potential here, but also maybe some of the commercial threats to some of the incumbent players. Now, why is DeepSeek a big deal for NVIDIA and company? We've all been focused on what's been called the scaling laws. And what are the scaling laws? Well, very broadly speaking, the scaling laws are the laws that says that if you want to make your AI model better, so make it more accurate, make it more precise, make it smarter, more intelligent, able to solve more difficult problems, well, then you have to scale the data and importantly, the compute you put into the model. And so the approach has been, really roughly saying, look, if you were using 100 processors for the last model, you can use 1,000 processors for the next one and 10,000 for the one after that. You sort of increment by a factor of 10 every time. And every time you do that, you'll get improved performance of 5, 10, 20%. Okay, and so these scaling laws are really what have been driving the performance and the improvement in model performance. And therefore, the received wisdom has been CapEx is the way to dominate. If you want to win this game, you got to throw more money at it. And of course, that's a game that US players are great at playing because who's got access to more capital and more deep pools of capital than the US industry and especially US tech industry. And so NVIDIA was seen as the undisputed winner of this because every time a new model provider wanted to compete, we saw that most recently with Elon Musk setting up XAI and really launching that into the world last year. He needed tens of thousands, if not hundreds of thousands of processors, and there was really only one place you could get those, and that was NVIDIA. And so DeepSeek is a potential paradigm shift in how we think of all of this. Okay, so that is what got people very worried, maybe for NVIDIA's future, and why you had that big wipe off of market capital. And so the first thing that happens after that, you have the worry and you have the recriminations. And people were saying, oh, the DeepSeek team, they cheated, they used more chips than they've told us, they stole OpenAI's data through a process known as model distillation, which is maybe a bit funny when you think about it in the sense that OpenAI really has created their business out of sort of borrowing the whole world's IP in the form of sort of scraping the internet and using that to train their model. But leave that to one side. There was the whole kind of notion that they were not quite playing by fair rules and therefore that they were somehow to blame. Uh, there's possibly a little bit of panic mixed with some sour grapes here as well, because the US players have not been used to that dominance being challenged by China. Uh, let's try to unpack some of these allegations a little bit. Let's try and look under the hood and see what we can learn and figure out. Is there some fact or some fiction in some of this? First question, did the model cost more to develop than claimed? I mean, first of all, let's look at what was actually claimed. If you look at the white paper released on the 26th of December, what this said was, look, the OPEX, so the model training cost of the final training run was $5.6 million. But if you unpack that a little bit, you can see that that's about 2,000 H800 GPUs from NVIDIA. H800 is the cut down version of the H100 that is specifically made for China because, as you'll recall, there are these export restrictions that the US has put in place. So a slightly less performant model, but still would have cost them $70 to $100 million to buy. So when we talk about did the model cost $6 million to train, well, certainly the equipment alone, the hardware alone would have cost more than that. But more than that, of course, is building a model is far more than just the last training run. There's all the development, all the data preparation, everything else that goes into building a strong model. Although, if you look at what they actually said in the white paper, they said, look, the final training one was $5.6 million. And if you look at the sort of estimated 2.8 million GPU hours for that final training run, that seems entirely feasible. So it doesn't seem on the surface of it like they've been sort of lying about the amount of hardware they've been using. The truth, of course, is that there's much higher cost to develop the whole model. And that leads on to the next question, the question that's often asked about these export controls. We talked about the H100, and the question is China playing by the rules here, or are they evading export controls? It's really interesting data when you dig into the NVIDIA financial statements and you look at where the chips are sold. Because it turns out that most of the chips are sold in the US. It's no surprise there. But another place that's a massive, massive customer of NVIDIA chips is Singapore. And so it's interesting to see that this, wonderful, but very, very small country with not very many data centers is a whopping 22% of NVIDIA's revenue base. In fact, when you look at the latest NVIDIA statements here, the 9 months ending October 27th, you could see that Singaporean clients purchased for $17 billion worth of NVIDIA chips. So does it seem plausible that some of that maybe have been funneled through to other geographies and been shipped off from there to China? Yeah, it probably does. So there's probably an element of should we say swerving or circumventing the export controls. But here's the thing, is the really big takeaway that I think people should take away from this. In the context of DeepSeek, that may not matter. Because much as we're talking about the chips required to train the models, kind of to make the model, the really big innovation that the DeepSeek team did was around the cost to run the model. So what we call inference. So once you build your AI model, you put it into the cloud, you put it on a set of servers somewhere, and you then use it to answer questions and do work. And kind of the really big question here is how expensive is it to run that model? And what the DeepSeek team was able to do was to deliver the inference, kind of that run cost, at a 1/20th of the cost of OpenAI. And so in our evaluation, that was really the big breakthrough. And this is not dependent on kind of whether they used, 1,000 chips more or less or evaded export controls or not. This is, simply because they were able to create some really powerful technology. And how do they do that? Well, the superb technical innovation is the only way I can describe it. They invented things like a multi-token prediction. So instead of predicting one word at a time in the model, sometimes if you use ChatGPT or Claude or the other models, you can see they'll sort of spell out one word at a time. Well, what the DeepSeek team enabled their model to do was to predict multiple tokens at a time, making the model much faster with less compute load. The other thing they did that was really clever is they developed something called a mixture of experts architecture. What does that mean? Well, these AI models, they are big things. They require a lot of compute. They are really kind of, if you think about it, one GPU from NVIDIA can be 30, 40, 50, $60,000. And so the hardware that you need to run these things is not cheap. And so you need a lot of hardware to run them because they're very big. And what the DeepSeek team did was they said, well, rather than activating the whole model every time we're trying to answer a question, why don't we do something else? Why don't we figure out which part of the model is required to answer this specific question and just have that, activate that little part of the model? And so instead of having a whole 6, 7, 800 billion parameters activated, they could activate 60 billion parameters. So much, much more efficient, very clever. And I think maybe in the brute force approach of the West here, where we were focused on scaling laws and just throwing more and more processing power at things, actually some of this innovation where you can just do things, like I said, just do things in a smarter way, were overlooked. I make this sound easy. It's not easy at all. The underlying technical innovation was very, very meaningful. The last thing they did that I would mention is, and we'll come back to this in a minute when we talk about NVIDIA. NVIDIA has built an incredible stack of technology, and one of the things they've built is CUDA, which is the programming language that you use to program the NVIDIA chips. Now, CUDA is, for those of you that know programming, is a little bit like C or C++. It's kind of a reasonably high level language that you can use to program, making it easier for developers to access and program the chips. But what the Chinese team did was they said, look, programming in a high level language like C or like CUDA, it's great because it's maybe easier to read and easier to access, but it restrains us in some ways. It means we can't use the full potential of the processes. So we're going to go bare metal here. We're going to use PTX, which is a little bit like machine code, and we're going to program straight to the metal. Much harder to do technically, but they could optimize the code and make it more efficient. There are other innovations they did. They used floating, 8-bit floating point as opposed to 16 or 32-bit floating point, and they found ways to make that accurate enough that it could work. So all this technical innovation came together to deliver this great performance. And of course, from a computer science perspective and from a business perspective, really, this is very, very interesting and very exciting. Now, there is more here because, when we think about kind of DeepSeek, we say, it's not, just because we see one smart thing coming out in China, does that really mean that the world has changed or that China is a big rival to the US? Well, it turns out that DeepSeek isn't alone, because just as we have the DeepSeek model, we also have ByteDance. They have the Duobao model. Alibaba has the Gwen model, which is also an open source model like DeepSeek. So we're seeing some excellent models coming out of China with really, really strong performance. And so this, of course, is something that's rattling the US model developers to some extent. And so the question is, when you look at this, and you're Sam Altman, what does that mean for his plan? And what's up with his $300 billion valuation that he's trying to raise at now? And all the speculation is really that he's trying to scale his way to a moat. And so if that's the approach you're taking, you're basically saying, look, the way I'm going to win this game is just to have, more and bigger and better toys than anybody else. You better hope that the scaling laws are going to hold up. And of course, as we saw yesterday, there's more fun in this incredible soap here that's going on, because enter this guy here, Elon, has now put a bid on the table to acquire the nonprofit portion of OpenAI, which controls OpenAI, for close to $100 billion. So lots of really, really exciting dynamics that are going on, and it's almost sort of, you've got to almost have a real time view on it to keep up. Leave that to one side, kind of some of the feuds between Sam Altman and Elon Musk. What does it all mean from a bigger perspective? What are the geopolitical implications? China versus the US. Where's Europe in all of this? There's a big AI summit here in Europe this week. Development models, is it open source versus closed source? What's going to win the day? You've got the value distribution. Where in the stack is the value going to accrue, and who gets to win? Is it going to be the model developers, the chip makers, or somebody else? And finally, kind of what does all of this mean for NVIDIA's future? Let's try and unpack that next. So, state of AI today. What's happening in the AI industry? The new tech stack is really an AI stack. We've got at the bottom of the stack here, we've got the semiconductor manufacturers like the NVIDIAs, the Groks, but also Googles and Arms and others. And then we have the general foundation model developers like the OpenAIs, Anthropics, Google, DeepSeek, etc. We have a new generation of models that are more vertical. So we have companies like a UK company, Wave here, that's developing an amazing model for autonomous cars. NVIDIA is developing a new model called Cosmos that's more about physical AI. We have all the AI and infrastructure tooling that sits on top. So the uh, tools to develop, optimize, manage, and secure the models. And then we have all the vertical applications that sit on top, specific industry applications in manufacturing, energy, construction, transport, logistics, agriculture, healthcare, and so on and so forth. And so if we think about what's been happening over the last few decades and over the last few years, well, the history of technology was originally about hardware. Um, and I'd say the last few years have been a return to hardware. So semiconductors were the foundation of the AI revolution, but they were also the foundation of the technology revolution. And so the tech industry used to know how important this was, forgot it a little bit. We just focused on software for a while. And the past 2 years, we've relearned that semiconductors really are the foundation of everything. And now, semiconductors, it's a large and quite complex supply chain. We often talk about NVIDIA as sort of almost as if they were the only company inhabiting this space, but it's a very, very complex world with lots of different businesses. Some of them American, some of them Asian, and also some of them European. We've got a great company like ASML that's very, very important for the industry. And we've got ARM on the IP side that's doing some interesting things, also working closely with NVIDIA and others. So it's a complex supply chain. Lots is happening, but however you look at it, it's clear that over the last few years, nobody has been able to come close to the rise of mighty NVIDIA. If you look at the way the share price has evolved since the launch of ChatGPT in November 22nd, you can just see here just how astronomical it's been. And if you compare that to others, well, market dominance, 90% gross margins, incredible in this industry. And it's returned 20 times the S&P 500 over the past 5 years. So it's been an incredible investment. In terms of valuation, it's valued at about 50 times sales, even after the most recent correction. So all of this assumes a continued dominance of the company. And so where does all that bullishness come from? Why has the industry been so excited about the business? Well, if we look at where the value has been accruing, if we go back to the cloud era, well, the semiconductor, sort of the hardware manufacturers, the people that made the physical stuff, certainly made some money, but the application developers made the most. Sort of the Salesforces, the Adobes, kind of these apps companies. Whereas in the first wave here of the AI era, the Gen AI era, most of the value has been accruing to NVIDIA and much, much less to the companies further up the stack. And so that's interesting, of course, if you think about where the revenue has been going. Now, the question is what happens next? Is NVIDIA, is it overvalued? Is it undervalued? And what we can do here is we can try and unpack that a little bit by painting both a bear and a bull case. So why don't we do that? The truth is, when we look at the AI adoption, we are still incredibly early in the AI journey. According to recent research, only 6% of US companies are using AI today. So it's clear that we have a massive upside ahead. And if you believe that AI is going to be big, and if you believe that all the value is going to accrue to the semiconductor manufacturers, well, then NVIDIA is going to continue to be a very well-performing company for a long time to come. And let's look at what it is they have done to create this dominant position. Now, the NVIDIA bull case, they've created all these multiple interconnected moats, starting all the way down here with all the GPUs, all the processors they use for model training and model inference. But that's not the only thing NVIDIA has created. They're also creating the CPUs, the Grace CPU that they've implemented in Grace Hopper, which they developed together with ARM. You've got the networking side with Mellanox, which is an acquisition NVIDIA made a few years back. Why is this so important? Well, it's because when you look at the training of these massive models, we've started talking about the unit of compute no longer being the CPU or the GPU, but the unit of compute being a data center, because you have to orchestrate and run all of these processes in parallel. You have to make sure there's real-time communication between them, and then networking, of course, becomes extremely important. And guess who's got the best networking for that? Turns out that that's NVIDIA. On top of that, you've got CUDA, which is the programming language everybody's using to program the processors. What that means is that all the AI models and all the programming that goes into making them is programmed by a language that's controlled by NVIDIA. And then on top of that, you've got these libraries, QDNN and TensorRT, which can be used if you are not using CUDA to program, but if you're using Python, which is another massively popular language, well, then you can link in with QDNN, and QDNN will then translate what you do into CUDA, so you get back into the NVIDIA ecosystem. Similarly, TensorRT can be used to optimize a model to make it run faster on NVIDIA hardware. So they've got all these amazing technologies and this stack that sits on top of each other, these interconnected modes. That means they just have a formidable business. So that's certainly part of the bull case. If we look at other things that might be part of the bull case, here's a second thing, kind of the cost to train models. The capital expenditure, the cost that goes into buying these processors. If we look at the first publicly available GPTs, a GPT-3 and a 3.5 released around the time of ChatGPT, about $50 million was the hardware that went into training that. GPT-4, well, there was the 10x there, the scaling loss, $500 million. And then GPT-5, which is being worked on now, at least 5 billion, if not a lot more. So we've seen these scaling laws really drive compute spend. And this is trickling through into the spend of the hyperscalers. If we look at the CapEx by the hyperscalers, that has just grown incredibly. I mean, Amazon, Microsoft, Alphabet, Google, and Meta. We saw recently Google releasing their earnings. There was an expectation that they would be spending, outlooking 60 billion of capex this year. They said, no, 75. We just can't spend enough money on capex to buy chips. And of course, this is driving NVIDIA revenue. So I would say this is the second leg of the bull case. Third leg of the bull case is that this is not just a private commercial endeavor anymore. We're talking about sovereigns here. Everybody wants their own hardware. The US, China, Middle East, the EU, UK, everybody is wanting to build their own models. And nobody more so, of course, than the US, and with Project Stargate, where we've seen an announcement of $500 billion going into this. And so that's a staggering amount of money. It's been discussed whether the money is there or not. We can certainly see a way to that money being available by the people that are participating in the consortium. I don't think it's unrealistic. $100 billion immediately to build the first 10 data centers. This has already started. Key players, the usual suspects, with OpenAI, Oracle, and SoftBank in the driving seat here. Interestingly enough, Elon Musk not part of it. So he was sort of out and poo-pooing it a bit, playing it down. Again, maybe a little bit of sour grapes sort of mixed in. There's certainly never a dull moment in the industry. But I think the takeaway from all of this is all this money being spent could be another $300 billion alone in sales for NVIDIA. So again, a staggering amount of money that could drive revenue for the company. Next leg of the bull case, we are not done yet. There are a lot of reasons, and it takes a lot of reasons, to be honest, to drive kind of a $3 trillion valuation, is the case of synthetic data. We sometimes talk about how we have data scarcity, how the internet is running out of data to train on, and what do you do next? Well, it turns out we have ways of making data. We can make what's called synthetic data. And what is synthetic data? Well, synthetic data is when we ask the models to make their own data, and we have developed some smart ways of doing that. Let me give an example. One thing you could do is you could take a topic where you have clear answers, and the answers are well known and they're objective. It could be maths, physics, anything scientific. And you could say to the model, here's the question, here's the answer. Now you try and chart a path between the two and find a way to reason your way, to calculate your way to that answer. And the way you do that is you do lots of inference. So you're saying do 10 runs, 50 runs, 100 runs, 1,000 runs of seeing if you can arrive at the right answer. And when you've arrived at the right answer, you know you've taken the right approach. It's kind of very kind of trial and error, right? A little bit like Edison and the light bulb. Um, but what turns out is that because you are making, so this is making data. And when you're making data this way, you're finding one way that works and 1,000 that don't work. Well, first of all, you're creating all the data. But second of all, you do it through inference. And that means you're running the model again and again and again and again. So it turns out that running out of data and creating new synthetic data to scale is a huge driver of compute, which of course, again, is back to potential NVIDIA revenue. We've talked here a little bit about inference. I would say that the next part of the bull case, reasoning and inference, we've seen the new reasoning models, both the R1 model from DeepSeek, but also the deep research models we've seen coming from Google with their Gemini deep research model and OpenAI's model, which are models that are, rather than trying to provide a very quick answer to you, they go off and they do proper research. They really, outline a whole set of research steps. What does that mean? Well, I might want to report on something. Maybe it's a scientific issue I want to solve. Maybe it's a technical issue. And the model will then spend 10, 20, 30 minutes to go out, research sources, look at white papers, research the internet, think, discuss with itself, and come back with a complete report that summarizes lots of different data points. Well, guess what? This type of model running, where it's not just a quick, question answer, but running in continuous inference, requires 100 times the compute that a simple query does. So further driving capex. So you look at all this stuff, and it's kind of hard to see, when will the NVIDIA train ever stop running? And this is the NVIDIA bull case. You've got the hyperscalers, you've got the sovereign AI, you've got synthetic data, you've got reasoning, you got this thing everybody's become experts on now, Jevons paradox, right? Going back to coal, kind of saying the more efficient the coal plants became, the more coal we use. Well, that's sort of the notion here is the more efficient AI models we get, the more AI we're all going to use. And so therefore, NVIDIA is going to sell more chips. Now, as we can see, lots of reasons to be bullish on NVIDIA. The question is then, are there reasons to be bearish? What are the forces pulling in the other direction? And there are some. One is hardware competition. We've seen some really innovative upstarts like Cerebras and Grok that deliver strong inference performance with their hardware. So we might say, how can these upstarts threaten NVIDIA being a big, strong, powerful company? Well, it turns out that the hyperscalers themselves, so the Googles and Amazons of this world, they've been developing their own custom AI chips. And actually, if you look at the number of chips units made and shipped, Google has got a huge number. The reason why we don't talk so much about that from a revenue perspective is because the main customer of Google's chips is Google. I mean, they're a huge, user of AI. They use it from anything from optimizing search queries to AI, to ads served on YouTube. And they made the tensor processing units, and they use them in their own data centers. So, it's not, you don't have to be creative to think about how this could evolve. If Google and Amazon, they all create their own chips that could displace some NVIDIA workloads. You also have the frameworks and the AI competition. So you have new frameworks like MLX, Triton, and JAX that could reduce the dependency on CUDA. And then we saw DeepSeek use PTX, sort of programming straight to the bare metal without using an intermediate framework. So that could threaten some of the strength there. Interestingly enough, LLMs themselves, kind of the AI models, could enable a faster transition away from CUDA if people can coalesce around an alternative. Now, there's one more thing, which is quite important, actually. We've seen NVIDIA as this unassailable company that just could do no wrong, but they've actually had execution issues over the last year. Blackwell, which is the next generation of processors, have been delayed by at least 6 months. There have been issues with performance, with yields, with overheating. That could be threatening the company. Then you have, of course, the cost evolution. The training costs might be less than expected. Inference costs might be a fraction. And importantly, if DeepSeek can price API calls, so the use of the model 95% cheaper than incumbents like OpenAI, how can NVIDIA still sell GPUs to OpenAI and Stargate for $300 billion? What's the business case that underwrites this if things become a lot cheaper? And that's where some people say, well, Jevons paradox, we're just all going to use a lot more. And maybe that's fair, but the question is certainly still lingering. And then the bonus bear case you have is kind of the OpenAI case, right? Because if the value of LLMs become eroded from open source, how do you justify OpenAI at $300 billion, which is the reported latest valuation? Now, there's another angle on all of this, which we think is quite exciting here. We're kind of at SuperSeed, we're mainly apps investors. And of course, we've been following and investing into the space, but also following the kind of how things have been evolving here between apps and the semiconductors. Uh, I showed this graph before about how in the cloud era, we saw most of the value captured by apps, but in the Gen AI era, we've so far seen most of the value captured by the semiconductor manufacturers. And then the question is, if you go back through time, do we have other analogies here we can use? And it turns out we do. Because if you look at the shift from the mainframe era, which really was Big Blue on top of Big Blue on top of Big Blue, to the client server era, you saw a massive shift there in power, and we know how that played out. Maybe the size of the logos here is quite right. Microsoft should probably be a little bit more dominant. But what was clear was that you had a complete flip. In the mainframe era, it was all about hardware, full stack integration, a little bit like NVIDIA. In the client server era, it became all about software and apps. And Microsoft, of course, was the poster child of that era. But what happened after that? Well, what happened after that was the dot-com era. And again, initially we saw lots of strong hardware players, Cisco's, EMC's, Sun Microsystems. They looked unassailable in 1999. Anybody knows where they've gone? Right? They've been absorbed by Oracle today. And then that went to the cloud era, where again, the value was accruing at the apps layer, whether it was Salesforce or Facebook or Adobe, or again, Microsoft. So again, we saw that shift from the hardware and the semi and sort of the lower layers of the stack to the higher layers of the stack. And we expect that we're going to see exactly the same paradigm play out again. Initially, we've seen NVIDIA capture all the value, but if this pattern repeats, there is this incredible opportunity in new application companies. And if we look at OpenAI today, going back to the question around what justifies a $300 billion valuation, well, it probably isn't the underlying model, but it probably is that they are becoming an applications company. We've seen how they've started doing a lot of business, not least with US government. Palantir is another example. You're seeing some amazing companies emerge in this space. This is, of course, what we think is so exciting from an investment perspective. That's where we see a lot of value being created and to accrue over the coming decade. So just kind of interesting to see how the pendulum has been swinging back and forth here. Now, we've been talking a lot about the industry. We've been talking about the industry players. They're all very interesting in and of themselves. The real question, of course, is there value at the end of the value chain? Does AI have real impact on the kind of real world around us, or is it just all kind of Sam Altman and Elon Musk show feuds? And the answer is yes. There is business disruption, and the software industry is evolving, and we're going to unpack that here in the final segment. So, firstly, let's look at what happens when AI basically removes or destroys product market fit. For many, many years, Stack Overflow was the poster child of the software and the cloud era. It was the place you went to when you were developing software. And over the span of a very, very short amount of time, traffic just completely collapsed after ChatGPT's release. It's the place software developers would go to get, to basically get reference knowledge of how to develop software, to see if I'm trying to solve this problem, who else has solved it before, and what are the best ways to do it. And it turns out that we can actually do that much faster, much quicker using ChatGPT or Claude or one of the other models. So that's happened, and Stack Overflow is today a shadow of his former self. Question, of course, is who is next? Is Uber next? Are we going to have autonomous vehicles that are going to replace kind of the traditional way of taking cars? What about Adobe? Is Adobe under threat? Their complex apps replaced by much easier to use AI apps? What about Spotify? If anybody has played with some of the new uh, platforms that can generate AI music, I would say there's certainly a threat there to Spotify and their business model of licensing known artists. Maybe you can just curate, music that's created just for you by another platform. Salesforce. Do we really need these huge enterprise platforms when we can do so much with AI today? And of course, the poster child of the internet era, the behemoth over all behemoths, Google search, is that next up as a potential business that's in the crosshairs of the AI wave? And all of these, I think, are fair questions. They're all kind of things that are under threat. So wrapping up NVIDIA and OpenAI, our assessment is that AI will be fundamental to the new economy, and it's going to create massive economic disruption and outcomes. NVIDIA is a powerhouse, but it is vulnerable in today's economy. There's no doubt. And around OpenAI, we've always said, you can't build a business just being a wrapper on top of an LLM. But it turns out that it's potentially the wrapper becomes the value, and it becomes all the stuff you build on top of the stack that provides real value to customers, and that's where the value accrues. So have we already started seeing some examples of this? Where is the near-term upside? What are the first new businesses to be created? And the poster child of the next generation of AI development is Cursor. Many of you won't have heard about Cursor before, and I don't blame you because it's almost so new that blink twice and you would have missed it. You would have missed it. Cursor launched about a year ago, and in a year has grown from 0 to $100 million in annual recurring revenue. Fastest growing application company in history. It's just been phenomenal. Cursor is an environment, is a place where software developers can go and develop software. It's kind of development environment. And what the environment does is it integrates very neatly with the AI models so that instead of having to go over to ChatGPT or go over to Claude to ask, how do I solve this problem? The models can look in your code as you're developing and help you change the code in real time. And it's beautifully done. It's just such a joy to use. And of course, that's why it's growing so fast. And what happens when you do this? Well, AI models alone from scientific studies are helping develop productivity grow by 26% across a wide study, but with tools like Cursor, it can go even higher. So we're seeing incredible productivity boost in software development as maybe the first industry to be highly disrupted. And the question then becomes, when it's so easy to make software, what happens to the SaaS industry? We can unpack that in a minute. But before we get there, let's look at some further productivity gains. Klarna came out last year and said, look, we were able to replace 700 customer service agents with AI, taking the resolution time of queries from 11 minutes down to 2. You have Microsoft on their Azure business, their cloud business, reducing the support volume by 25% by using GPT. And you have Meta, which I think is probably the most interesting case study of all, have been able over the last 2 years to grow revenue by 40% with 14% less headcount. And if you look at their strategy, especially around their open source strategy of Llama and the way they've embedded AI into everything in the company, they have simply just taken the bull by the horns and said, how can we make the most efficient business possible using AI? And kind of those kind of efficiency gains of a business of that scale are phenomenal. So very exciting AI productivity gains. There's no doubt that this is real and happening in businesses all around us. I asked before, what happens with the SaaS industry when it becomes easier to make software? So let's look quickly here about what lies beyond SaaS. The global SaaS market has grown to $300 billion, give or take, of revenue. And it's been a great ride here over the last decade and a bit. If we take a step further back, the history of computing really has been one of processing structured data. And if we go all the way back to the early mainframes, it was around taking data that was already quite well structured, like banking transactions or airline reservations, and then putting them into an automated workflow on a computer. Then you have the personal computers that enable knowledge worker productivity. And then SaaS really focusing on digitizing existing workflows and moving them to the cloud. To some extent, mobile has enabled the sharing economy, but it's still relied on semi-structured data. So data where you have some structure to what's going on, it's not completely unstructured. You've got some rows, you've got some columns. If you're booking a car, you have an address. There's some structure to the data you're working with. The challenge we have in the real world, in the physical world, is that it's a world of infinite edge cases. And so even simple tasks have been defeating robots up until this point. We have the case study from Apple that spent billions of dollars trying to automate the manufacturing of iPhones, and in the end gave up. And they gave up because they said, well, human adaptability beats machines. It's just too hard. The machine drops the screw and can't figure out how to pick it up. And there are too many little edge cases that we can't automate away. And so because of this, 80% of the world is still analog. Manufacturing, energy construction, so on and so forth. Yes, of course, there's a level of technology used, but most of the work is really analog work. We haven't found a way to use AI to automate it all. And so that's what's so interesting in the next evolution of AI. Now, initially, you had classical machine learning, which again needed structured data to understand what was going on, structured data to analyze. But generative AI, the next generation of AI, thrives on the messiness of real world data. And so it's got superhuman pattern recognition, and it can do complex reasoning. And this is this big shift we're seeing these years. There are kind of a number of technical breakthroughs that are enabling this. Firstly, the LLMs, they understand messy input sometimes better than humans. I mean, it's incredible to see how, maybe you've tried it yourself. You have a thought you can't quite express, or something you're not quite sure about. You put it into an LLM, use something like Claude, and you'll say, like, here's what I'm trying to say. And it'll oftentimes be able to put better words on what you're trying to say that you could. It'll catch the gist of what we're trying to express, but it also turns out that it can use that in a lot of other ways. It'll be better at catching, a cancer pattern in a medical image, or better at, processing a large amount of data to catch some pattern we couldn't quite figure out. And that's the second piece. It's the data abundance, because with cheap sensors today, cameras and sensors and manufacturing equipment or agricultural equipment, we have infinite training data. We've never had this much data. So we have infinite data, and the models can finally understand it. We also today have models that can continuously improve. So federated learning, dynamic AI enables models not just to be trained and used, but to be continuously updated, which is really important when you're in this massive real world. And then, of course, we have the cost reductions, right? Kind of this back to DeepSeek. The cheaper open source LLMs enable cheaper autonomy. And so because of these technical changes to how the world works, we see the next generation of the software economy as being really 10 times the SaaS economy when we look at what can happen in manufacturing, in agriculture, in healthcare, in logistics, and so on and so forth. So that is in many ways the next generation of AI and of software. It's the physical AI era. And what are the founder implications? What are the investor implications? Well, firstly, the market size is going to be a lot bigger than pure software, because we're going to start to tackle the real world and what happens there. Competitive advantages. It's technically harder to build than a simple cloud app, because you have to know not just what happens in the data center, but also what happens in the real world. If you want to build a strong AI for medical research, if you want to build a strong AI for biology and biological research, you have to understand a lot more than just computer science. And so we think that's really exciting, because that creates some new technical moats in the form of these cross-functional teams having to come together. It also means that expertise and what constitutes an expert team changes. You got to back teams that are not just computer science specialists. They also need a deep technical expertise in areas outside of computer science. So lots of exciting implications from an investment perspective, and so much, so many great companies being created right now. Now, let's before we round off, let's look briefly at the UK and the European perspective. We've talked a lot about kind of what's happening out in the big world, and it's been clear that we are technologically under threat and economically under threat here in Europe. The economy has not been performing well the last many years. You've got Germany, which has not grown its economy since 2019, and other large economies have not done much better. And the thing is, there are more punches coming, if you will. One of them is, kind of these super affordable EVs coming from China. You could say, why are cars so important? Well, it turns out that automotive is sort of the core industry of Europe, and kind of German cars have been, the best in the world for a long time. And suddenly, well, they might still be very, very good, but the challenge is that we're all transitioning to EVs, and China can produce those at a fraction of the cost. Then what does that do for our automotive industry? The second thing that's going to hit that automotive industry is autonomous vehicles. We talk about self-driving cars. Sometimes people joke it's never going to happen. Well, turns out it's already happened. If you look at San Francisco, Waymo, fully autonomous vehicles are now delivering as many drives, as many rides as Lyft, which was the other big competitor to Uber. 4 million autonomous trips completed in 2024, 150,000 trips a week. Totally autonomous, no drivers. Okay, so we can kind of all see where that's going, and it's not going to be many years until we have that on streets elsewhere. And of course, that's going to upend what it means to make good cars, because you go from shifting from being a specialist on making engines to being a specialist on making software. And we've got a little bit of catching up to do there. And from a capital perspective, it takes $300 million to make a unicorn. Europe is still behind on capital. There's a lot more venture capital dollars available in the US, especially for scale-up companies. But of course, this is also an opportunity from an investment perspective, because if you look at really the core ingredients of creating a great company, well, it is talent. And if you look sort of, in the Western talent pool, well, more than half of the top technical clusters on Europe, Europe is almost 40% more software developers than the US. So you've got some incredible talent in Europe that is ready to build businesses and that we can invest into. And it turns out that that talent has been busy building companies. There is now, one Series A for every two in the US. It used to be a much, much different pattern. So we're not quite at 1-to-1 yet, but the ratio of US to European Series A's has become much, much better over the last couple of decades. And what that's doing is it's creating, it means we can create a lot more value here in Europe. And when you go back to the 90s and kind of the dot-com boom, only 5% of the value of the global tech industry was created in Europe. And if you look over the last decade, that is now increasing to about 18%. So there's a lot more enterprise value being created in Europe, and that's of course exciting. That's where the potential is coming. We see that increasing. On one hand, we can say there's less capital, but yes, this is also an opportunity because it means less competition to back these great founders and help them build good companies. And as we can see, more and more people doing that, and that's why they're great businesses being built. That's what we do here at SuperSeed every day. Here's a select a number of companies. Most of them are vertical application companies from our portfolio. Those of you who were there on the Investor Day had a chance to meet some of the founders in real life. We'll share some of the interviews and some of the things they said here after the call today, so you can have a chance to hear from them how they see the opportunity. But all that's really left for me to do here now is to round off and say, look, what's next is this opportunity of the physical AI era. We think it represents a massive opportunity for the UK and for Europe. The AI stack will transform industries. It will create new ones. And we are here to work with the great founders that make it happen. And so thanks for your time so far. What I'll do now is we'll open up for Q&A. So they should be in your Zoom interface here. There should be a little Q&A panel where you can click the Q&A panel, and then you can put in any questions you may have, and then we'll try and answer them if there are any.
Mads, while people are having a ponder, Alex jumped the gun a little bit. Thank you, Alex. He was talking about DeepSeek, and he was asking what are the implications of DeepSeek specifically for Europe. Don't know if any thoughts on that.
That's a very, very good question. The first question that came was maybe typically kind of European recrimination, which is, we've got Mistral, which was Europe's great hope on the LLM side. And the first question was, look, for 18 months, we've been saying that it's hard for Mistral to compete because they don't have as much money as the big US model developers, and therefore they can't buy as many chips, and therefore they can't make models that are as good. And it turned out that there are other ways to innovate than just to spend money. Now, what's happened since then is this week Mistral has released an upgrade to their chatbot. It is impressive. The demo especially is very impressive. I must say, um, having used it in live, I still think that Claude and GPT 4.0 are stronger and faster. But there's certainly innovation happening. So this is the first thing I would say. The second thing is, and this is coming back to when we spoke about where the value accrues. If you have open source LLMs, and if open source models become as good as closed source models, well, that means that that's not where the value is going to accrue. And that means that you get cheap AI. And if you have cheap AI, what does that mean? Well, that means you're going to have a lot more AI you can put into apps. And so coming back to our strategy and our philosophy, well, that's all around backing the apps developers. Why? Because that's where we see most of the value accrue as the other layers of the stack commoditize. So the direct answer is, I think the open sourceification and the commoditization of the LLM layer is great news for us in Europe.
Amanda has asked, this is a really tough curveball. What's next after LLMs?
So we see amazing development in the vertical AI models. I mentioned Wave briefly, which is kind of tied in with this whole discussion around what's next for the European automotive industry. Well, it turns out that one of the leading companies on software-defined vehicles, software-defined cars, and autonomous driving is UK-based Wave. They've got incredible models, an incredible team, and we see companies like them being able to go in and develop the software you need to deliver the next level of autonomous vehicles. But that's not the only space. We see models emerging in other areas, in chemistry, in biology. We've got a very exciting business we're working with right now in biology that we think is going to create an incredible model that isn't a general foundational model, but is a specialized vertical model that can be used to solve very specific things in a specific domain. So what we see happening next is, from a model perspective, is really is that shift from generalized models to highly, highly specialized models.
I don't know if we have time. I think we've only got a minute and a half left, but Gavir asks, how are you seeing AI affect real world businesses serviced by your portfolio? So how is all this affecting the real world on the other side of the portfolio?
So this has been a very interesting development. I would say the first year, 18 months following the launch of ChatGPT, what we saw was companies sort of almost going into panic mode. And anybody that was trying to sell an enterprise solution that wasn't around Gen AI, even if it was a good solution with strong ROI, were just, sales cycles were just extended because kind of corporate, executive teams and corporate boardrooms for like, we've got to be all in on Gen AI. We don't want to be left behind. What we're seeing now is that shifting to the next level. We see a lot of the initial experimentation, a lot of the sort of initial testing coming to a point where people have started to figure out where can it help customer services, customer support, knowledge management, and are starting to implement those models. Some of those technologies are delivered by our portfolio companies. Some of them are delivered by other businesses, but we're starting to see a lot of real world application and return on investment for customers in this. Now, I will say it's still early innings. We go back to the chart from earlier, 6% adoption across the US economy. So there's a lot more to do, but we're starting to see the real signs. And of course, this is the exciting bit, right? When you really can start to see either revenue increase or cost savings.
We're out of time.
Okay, well, listen, it is now 10 o'clock. Thank you so much, everybody, for joining us today. We'll share the recording here. Of course, as always, feel free to follow up if you have questions, want to discuss any of this more. And otherwise, we look forward to keeping the dialogue up. 2025 is shaping up to be perhaps one of the most exciting years in technology ever. and privileged to feel we have a front row seat here to so much of what's happening. So looking forward to sharing our observations with you throughout the year, and hopefully also making some great investments together. But that's it for today. Thank you so much for joining, and have a great rest of your day.